Thanks to everyone present there. I am Pradiv Singh of class 10A, studying in DAV Public School, Bakri, Muzaffarpur. So, to participate in ATL SPACE Challenge 2021, I have made AI and ML driven satellite onboard computer. As we know that the exploring and reaching space is full of challenges. Back in 2019, when Chandrayaan 2 lost connection and couldn't make landing on the moon's surface smoothly. And similarly, a Russian satellite got struck by an asteroid. As well as we suffered a lot of problems to transfer raw data from the satellite to manually study it to gain some knowledge about that subject or planet. Similarly, every challenges is known, and even ISRO, we are a victim of that challenges. Uh, in the Chandrayaan 2 mission, in Mangalyaan mission, even in the Chandrayaan 1 mission. So to solve these kind of problems, I have made this device. I have made this device which is lightweight and installed in mini satellite as well. So in this device, we have used Raspberry Pi as the main component and the brain of the device. Coming on to the next component, it is relay module. We are using it as to depict the RCS thruster, that is left and right. This is RF module to communicate with the satellite. This is triple axis gyroscope, that is X axis, Y axis and Z axis. This is flex sensor. These are the libraries that we are using in different algorithms and programs that is mentioned above. After assembling it and rolling out the prototype, it will look like this. We have integrated and programmed 4 types of programs in the Raspberry Pi to overcome these problems and to develop this device, that is asteroid.detection.py, lander.py, resources.py and satheld.py. So asteroid detection.py is a type of Python program that we are using to detect asteroid that is incoming towards the satellite. It can estimate its speed, its size, its perimeter, as well as its shape, and in what time will it get to it. Even it can predict its trajectory by using Neuralink machine learning algorithm that we are using in it, and it can also amend its orbit or the trajectory to move on to dodge that asteroid as well. Similarly, in lander.py, this program is also programmed in with Python language, and this program is just for the landers, just like in the Chandrayaan 2. Back in Chandrayaan 2, the connection is lost, and we lost that lander. So to overcome this, we have made lander.py. In case of the lost connection, it will take all over the control of the satellite and over to it, and will run the satellite according to it. The satellite, this program will integrate all the sensors and transponders to be used to make land on the lower on the surface of any subject or planet or anything, with all the parameters that are mentioned, just like velocity, the altitude, the descent, the angle of the descent, as well as the thrust to be used properly to reserve fuel as well. So we will discuss later on lambda.py. Similarly, as resources.py, it will this Python program will analyze the pictures or the raw data of the planet or the subject by the machine learning algorithms like Neuralink, NumPy, pandas and etc. With the help of existing resources and the existing data about that resource, and it will provide us the synthesized data to ourselves without using much of the data transfer rate, and it will save a lot of time with the help of so lander.py self level the satellite as if it is imbalancing the lost connection. It will use the elevators as well as the thrust to balance itself with the help of the gyroscope as well as the RCS thruster, the left and the right. After that, the CV2 library, NumPy, as well as the machine learning algorithms like Neuralink will come in play to find the flat surface and the landing area to be landed on it. After finding the landed site, the device will reduce the velocity and approach the landing site with an angle of descent with the use of the HC504 ultrasonic sensor, and it will approach the landing site by maintaining an altitude of 100 meter. When the satellite got diagonally upward the landing site, it will reduce the velocity, and the main thrust will be on that will get diagonally down, and the legs will be extended on that so that the lander can land. And finally, the device will get up to the landing site and make a smooth landing, soft landing over the landing site. And this whole process will be automated by the device. Coming over to the resources.py, here this Python program detects and recognizes the resources that is got onto the surface of the subject, through which it can give out the exampulated data and manipulated data from the raw data as an image of the subject. These are some of the kind of the manipulated data that I got from the device by analyzing and getting over the informations from the raw data through machine learning.